Let's focus on framing the problem. This is a continuation of our discussion on the stages and steps of quantitative analysis. So we previously discussed the 3 stages of quantitative analysis that includes first framing the problem, solving the problem, then communicating and acting on the results. This lesson will focus on framing the problem, the first stage of quantitative analysis, and this is based on a discussion that's included in the book Keeping Up with the Quants by Kim and Davenport. As a review, here's the more detailed steps, the 6 steps that are part of those 3 stages. So again, we're framing the problem, solving the problem, then communicating and acting on the results. So once again, we're going to repeat this many, many times. So as we frame the problem, we'll go through problem recognition, we'll review the previous findings, then we'll move on to solving the problem through modeling, data collection, and data analysis. And then the final stage and step for communicating and acting on the results, we'll present the results and take actions. This session will focus on that first stage, framing the problem, and we'll look at problem recognition and reviewing the problem. Problem recognition, how do we recognize that there is a problem that needs to be addressed through quantitative data analysis in some form? So there are many ways that this comes about. How do problems come to us? As a data analyst, how do I come up with a problem? So it may be that there's just something that you're interested in. So curiosity, you're interested in answering a specific question. It may be you may recognize a problem based on your experience in a job or a company or an organization. So you may be a data analyst in the organization, but you may be or may realize that over time that there are specific questions that could be useful or problems that could be addressed through quantitative analysis. There may be an important decision that has to be made in the organization or in the business, and that's how you recognize the specific problem, and it may be assigned to you. So you may be given a very specific project, or if you're working in a consulting capacity, there may be options where you can choose whether or not to accept the data analysis project or not. So there may be some current issues, there may be previous research that needs to be updated. Maybe there's data analysis that was conducted through the previous fiscal year or previous operating year, and it needs to be updated. So many ways that problems can come to us, and that's good. And there are different ways that they can be addressed. And one of the things that we're going to focus on in this lesson is how do we frame the problem in a way that we can move forward to solve the problem, or at least analyze the problem through data analysis. So solving the problem, there's a lot more steps than just performing data analysis. You may be able through data analysis to identify the source of a problem or identify some of the key variables that are associated with a problem. But you're going to see that it's not as clear cut. And this is why we're constantly having to make some judgment calls as we go through the problem recognition and framing of the problem. One of the key things that we do early on, once we've identified there's a problem that needs to be addressed, maybe you've been assigned a project, a data analysis project or problem that you need to solve in some way. So one of the key things is to identify the stakeholders. Maybe you're told who those stakeholders are going to be. So who's the key person that needs this information for a decision? there may be more than one person. So, and it's oftentimes there are multiple people that are involved in knowing and understanding the data. So you're going to have to, at some point, you're going to have to present the results to the stakeholders or to one or more of the stakeholders. So this is a key part of it. So you want to perform the analysis to make sure it answers the questions for the right stakeholders. Is it the CEO of the company? Is it the chief operating officer? Is it your supervisor? Is it someone, a client that you're working with? And maybe the project came to you through an intermediary, so someone that's working for someone else, and they need the answers. So that's a big part of any project, any problem, whether it's data or not, is identifying who's involved and who's going to receive and understand the results, so who you're going to have to communicate the results to. In the Keeping Up with the Quants book, there is a stakeholder analysis worksheet, and I encourage you to take a look at that. At this point, when you go through a project, there's a project you need to identify. Think about these things, these questions that are asked. There's 6 questions that's part of the worksheet. Is it clear, for the number one, is it clear what executives have, or which executives have at stake in the success of your project? Have they been briefed on the problem and the outlines of the solution? Do they have the ability to provide the necessary resources and to bring about the business changes needed to make the project successful? Do they generally support the use of analytics and data for decision making? Does the proposed analytical story and method of communicating coincide with their typical way of thinking and deciding? And do you have a plan for providing regular feedback and interim results to them? So all of those things are going to be important, and managing expectations is one of the key things that you have to do as a data analyst in terms of a timeline, what the possible results may be. So be careful with your words and your promises as you're framing the problem. So that's one of the key reasons why framing the problem is so important. So know what you're getting into. It may not be your decision whether or not you complete the project or not, but you can help manage expectations to make sure everyone that's involved is realistic and the outcomes and what the outcomes can present. So we want to identify the stakeholders. We want to document their needs. We need to assess and analyze the interest and influence of the stakeholders. So maybe this is not a primary or very important project for the stakeholders. We need to understand what actions, if any actions, can be taken as a result of the project, and continue to review each of these steps, because this may change over time. Maybe the people have changed, maybe the stakeholders have changed, so maybe there's a new CEO, maybe there's a new manager that wanted this data, and it may no longer be important to that person. So it's important to keep your project status is updated as with any project. One of the key things to try to understand early on is what type of story are you going to tell. So you may not know what the result is going to be because you don't even know if you have the data yet. So do you have the data that you need to do the analysis? But the book that we're reading, Keeping Up with the Quants, categorizes it in at least 3 different types of stories. It's useful to think about it now because as you go through this process of analyzing the data and then presenting the results, ideally you're going to present the results in a way that you tell a story that is going to be the most effective possible. So we start with the CSI story, and CSI is just an example of a popular TV show in the past, the Crime Scene Investigation. So if you ever watched one of the many CSI series, you'll know that it's a crime series where there was a problem. So there was a crime that happened, and it usually was a murder or some other type of problem. There was a crime scene, and there are pieces of evidence that had to be collected and processed, and some result in terms of identification or something, or other clues were compiled and communicated to other people. So CSI type of story just means that there's not a lot of, we were relating this to a data project, there's not a lot of deep statistics that's involved. It may be some basic descriptive statistics, but there's likely good data that's available and standard reporting that's going to be necessary. So this is an important story, but it doesn't necessarily include any advanced statistics. There may be possibility that it does, but this is just one story. So there is a problem that exists in your company, and you have the data to perform an analysis and communicate the results. It's pretty lockstep. It may not be a major problem. It may be something fairly small, but it's there. So that's why it's called the CSI. It's procedural. It's something that happens on a regular basis. Then there's a eureka problem. So you think about eureka. So eureka, you have an idea or you struck gold. Eureka. So we think of eureka as a big problem that you're trying to tackle for the company. So the company is, maybe it's a new product development. Maybe this is something that will change the way the company does business. So a major problem, a major change in the company or project that you're working on. So in the eureka story, you have a very specific problem. It's usually a big problem, and it's usually a bit longer. So it may take more time. It may be released in phases, and is likely very important to the organization. Then there's a mad scientist story. So think about mad scientists, and it's really not a mad scientist, but this is a good way to help remember it. So if you think about a scientist using the scientific method, we have a hypothesis, and we're usually designing an experiment of some form to test the hypothesis and then present our results and whether or not our hypothesis was supported or not after we tested it. So after we held an experiment. So you can think about experimental design. And we've talked before about experimental design, and one of the common examples is with drugs and pharmaceutical companies or vaccines. Right now we have a lot of vaccine experiments going on right now, experimental designs in terms of trials, where you have tests, where you have a control group and you have a group that's receiving the vaccine. So that's the variable group, or the treatment group. That's where the variable is being adjusted in some way. So for the vaccine trials, the variable is whether or not they've received the real vaccine or not received the vaccine. But the same could happen for a website, let's say, or a store. Let's say you want to test your major retailer with hundreds of outlets across the country, and you want to test whether or not a redesign of the layout of the store will impact sales. Or it could be a lot of other metrics that you could test, but let's say we want to see if it will impact sales, so daily, weekly, monthly sales. So we have hundreds of stores, but we're going to test this on one store or 5 stores. So we're going to test this on 5 stores and then compare it with 5 similar stores where we're not making the change. So it's an experimental design because we're testing it, and and we have control group, we have a group where we're doing something slightly different, and then seeing if there's a significant difference in the results. Is there a significant increase in revenue, in sales revenue from the stores where we change the layout of the floors, or is it opposite to our hypothesis? So we have a hypothesis going in and we test it. There's another term for this, and it's usually related to websites and email marketing, lots of marketing. It's called A/B testing. So you have two options. Maybe you have the same promotion, but you're selling it using different language or different advertising. So you want to see which ad or which image or which text is most effective. So you can send option A to half of the consumers, half of the customers, and option B to half of the customers, and to see if there's a difference in response. So that's the mad scientist. So you're doing some form of experiment in some way. Then there's survey stories. So these are all different types of stories that you might tell with your problem that you're trying to solve, and then you're identifying data to solve the problem or to analyze the problem, and then you're going to act on and communicate those results. So survey story is another type of story you may be telling, and that's pretty obvious what this one is. You're using surveys to collect data. So maybe the surveys have already taken place and you have the data, or maybe you have to design the survey. Survey data is pretty easy, but it's also not easy. So it's easy to create a survey, but it's difficult to create a good survey that is precise in what you're trying to measure. So the way that you word the questions in a survey are very, very important because they have a big influence on the results that you'll have in the survey, and the type of analysis that you can do. So if you allow users or customers to answer a question as yes, no, so a binary option, yes or no, after asking the question, or is it there's very limited types of analysis you can do with yes and no. If you use a rating scale, so it's a 7-point scale from strongly agree to strongly disagree, and you ask participants or customers, how strongly do you agree with this statement? And they rate it on a scale. There are more types of analysis you can do on a survey data that's scaled like that. So you have to have some idea of the story you're trying to tell, the type of, and even at this point, the type of analysis you may want to do or may need to do for the purpose of this problem that you're attempting to frame. It's not going to be perfect. It's going to change, and you're not going to have all the answers up front. The fifth example of a story is prediction story. So prediction is also pretty obvious in its name. So we're going to try to use predictive analytics, predictive modeling, such as regression analysis, to try to identify key factors, key variables that may predict something. So I'm using a lot of consumer behavior examples in marketing. So because this is very common in marketing. So we're trying to predict the factors that are tied to purchase. So we want to predict whether or not a customer is likely to purchase a product. So maybe it's based on website data. So if we know that the number of page views and the amount of time spent on a website and sessions on a website will predict whether or not a product is purchased, then we can identify or target specific offers to those customers if we find that that's a key factor. So we want to know what those key factors are, and then we can make decisions that will help us perform better as a business. Then there's the number 6 story, and these are not all encompassing. There's variations of each. There's overlap in many of these, but the number 6 story is a story that we're trying to tell about here's what happened. So that's the story. Here's what happened. So we're really taking data, we're taking reporting and facts about what's occurred, and we're explaining and maybe using descriptive statistics, and maybe using data visualizations to explain when and where different things happened. Maybe it's sales, maybe it's decline in sales, maybe it's increase in sales, maybe it's how the COVID-19 pandemic impacted sales beginning in March 2020. So here's what happened. So this is a story where you're explaining, here's what happened, and without necessarily providing a recommendation for or solving a problem, we're trying to understand the problem in most cases. So we know that something happened, we're trying to understand it. So then we're going to move on to, before I move on, I also wanted to talk a little bit about, I mentioned the word hypotheses and hypothesis. So a hypothesis is something that we're attempting to test and see whether or not it's true or not. So if you've taken the statistics course, and I think you probably have by this point, you're looking at, you work with hypotheses in hypothesis testing. So you have something that you're trying to, you have a statement that you believe is true, and you're trying to support or not support the statement. It's really a key aspect of the scientific method. So we believe something is true. So we believe, let's say we believe that if someone visits our store in person, they're more likely to make a purchase than someone who does not visit the physical location of the store. So that might be our hypothesis. So there are different ways to test hypotheses. So I wanted to make sure that you start thinking about hypotheses. So there's some examples in the Keeping Up with the Quants book about the types of hypotheses that you can test. It's good to think about your hypothesis. You may think about this as a question that you're trying to solve, but it is a question, but it's usually written in the form of a statement, and then you're trying to support or not support the statement. And when you're writing the hypothesis, it's important to think about whether or not you can actually test the hypothesis. So if you were able to collect data, can you actually do analysis that will test the hypothesis? So your book gives you some examples of hypotheses. So for example, here's one hypothesis. Years of education is a good predictor of the level of performance rating an employee will receive in knowledge work jobs. So in certain types of jobs, we believe that years of education is a good predictor of their performance rating in knowledge work jobs. So that's a hypothesis, and something that could potentially be tested in lots of different ways. So we could survey people. So I'm thinking about surveys. So we could survey people and see if they, what their performance level is, and ask them some demographic information about their years of education. Do they have high school education? Do they have post-secondary education? And how many total years is a demographic? We could ask them for information about their performance evaluations. And then we could see if and then ask them about their type of job to see if it falls within a knowledge worker category. And then we could do some analysis. We could do some hypothesis testing. We may even be able to do some form of regression analysis to see if that a variable, if education is likely the independent variable for in performance rating would be the dependent variable, the outcome variable that we're trying to predict or to see if there's trying to understand the factors that go into it. So I know that's a lot of information. You don't have to know the precise ways to write a hypothesis right now, but it's good to have a statement because that when as you're thinking about stories or you're thinking about problems, being able to communicate the hypothesis is important. The next part of framing the problem is to review the previous findings, and this is there's a few ways to think about it. So one is to don't reinvent the wheel. You may have heard that before. Don't do something if there's already examples. Don't try to create something brand new if there's lots of examples out there of effective ways to do the same thing. So there may be methodologies or examples or even data that's out there that's already related to your problem. So you've got a problem that you're trying to address in your company or organization. You want to see what's been done before. So it could be, you could do a Google search. That's one of the quick ways you do it. You can look through your library database. So especially if it's a more of a advanced technique that you're trying to find some example about optimization and supply chain management, you may want to look at academic journal articles, or it may be on a website somewhere. Other ways are just to talk to people in the company, talk to other data analysts in your company, or attend conferences. This is another important way. So having professional connections in your industry. So if you're working as a data analyst in supply chain management, so having connections in the industry and professional organizations that's tied to your job, your company, is important because there may be others that have addressed the similar problems. So then you go to meetings and you do some networking and you talk to people and ask if they know about this issue. Is there anything that they know? Or maybe they have a website, an online networking website, and you can post the question online and you can see if anyone has any answers to it. And I encourage you to do all of those things because having a strong network can be key in helping you find answers so that you're not trying to create something brand new on your own. So talk to others, talk to other people, see if there's any files in your, let's say if you have shared documents or past reports, check those sources first to make sure that it hasn't been done in the past in your own organization, because maybe it has, or maybe the data is already there. There's also a few other examples that you need to focus on in the book. And one thing that's really important is the worksheet for framing the problem. This is on page 48. These are some questions to ask about as you're thinking about the problem, as you're thinking about an issue that you're trying to address, and it could be something related to your company or an organization that you're familiar with. Maybe you worked with them, or maybe you volunteered, or maybe it could be the university is another issue. So what's a problem that you know and could be analyzed in, with quantitative data? Frame the problem, go through the steps of problem recognition, trying to understand the problem, who's involved in the problem, who are the key stakeholders, what kind of story could we tell to address and communicate this problem. Start thinking about at least one hypothesis that could potentially be tested from that problem, and then moving into reviewing previous findings. What kind of research, where do you start? What questions do you ask? Who do you talk to? And then do that research to try to review prior findings to see if there's anything similar that's been done. And it may be something that's been done publicly through websites. Again, databases, professional organizations are some of the key places for that. So this has been a good overview of framing the problem. And if you want to see some specific examples that go beyond this, at the end of your framing the problem chapter, and this is chapter 2 in Keeping Up with the Quants. At the end of the chapter, there's 2 examples that go through the full 3 stages and 6 steps that help maybe put some of those things in perspective. So again, we've been focusing on the first stage of framing the problem, but the 2 examples that are at the end of chapter 2, they also they also go through the remaining steps of stages and steps. Next time, we're going to begin working on solving the problem, which is the next stage in our 3-stage approach for quantitative analysis.